I have a pen. I have an apple. Apple pen.
Okay, welcome to Log Again, where we, Team Log Again, present to you logarithms again. Let me introduce you to my team members. Jie Er. Hi. Adam Rosman.
Hi.
And me, Melinda. Okay, let's get started. Welcome everybody. Welcome to Logarithms Again, presented to you by Team Log Again, consisting of Adam Rosman, Jie Er, and myself, Melinda. So, what this video will be doing, or the questions that we'll be answering today, are the following. So, what is logarithms? What is pH? How they relate? And then we'll show you a little experiment, followed by a demonstration of how we find pH values from concentration using log, and vice versa.
Okay, so I'll be explaining what is log about. Log is an inverse version of exponential function. Technically, it means that log undo exponential function. So I'll be teaching you how to convert log to exponential function and exponential function convert to log. So this is exponential function and this is logarithmic function. To convert from exponential to log, you have to treat b as a base and y, which is the value of b power of x, and when it comes to log, it will be the number beside log and the base. For x, which is the power of b, when you convert it to log, it will be the value of log base b, y. Then, when we plotted both equations in the same graph, it looks like this, which logarithmic curve is the reflection of exponential curve by the line y equals to x. So this is the inverse version of exponential function, exponential version, and this is a logarithmic version. So how does the reflection form? Is that, remember, both So how does the reflection form? Is that, remember, logarithmic function is the inverse version of exponential function. So we have to switch the x and the y value in exponential curve to get the point in logarithmic curve. So that's how reflection are formed.
You can see here we have these solutions. We have Clorox bleach, we got soda water, and dark espresso. Okay, now we already poured them in cups and we dipped them in litmus paper, as you can see right here. If you can't see it, then too bad. So dip them in and we'll see if they live up to the expectations with this pH scale. Thanks so much to the Taylor's prep room. These scales. Just put them down like this, as you can see. So this is a light colored one, and this is a dark, and this is an even darker colored one. I'll let that stay off. Okay, now as you can see, that pH, well, it seems kinda unreadable, but we'll edit that in post, so don't worry. And
The pH levels later evaluated off-screen were 4 for coffee, 7 for soda water and 12 for bleach. Just look at this stupid loser having an existential crisis xddddd.
Okay, so hello, this is the equation. As you can see, this certain equation right here, you'll get into this pH level. So you either have concentration to find pH or the other way around. So let's start with something simple. Let's start with bleach. Everyone knows bleach, right? It's a classic internet joke. Okay, and then, so basically right now you gotta put the negative the other side. Really easy stuff. Honestly, really. Now, here is where the application comes to mind. Because we know that log, when switching to the other side, is base 10. Now, being that it's based on one side, it's based on the other side. But this, you apply log. Now, what if it's have to move to this side? Now, this what will happen. 10, base 10 will still remain as base 10, and it becomes negative 12 on top as the power, and it will become so. And you'll have to add this long thing right here. There you go. And equals to this. You can treat this as an x, you know, it doesn't matter right now. You can treat this as an x. You just implement to here, to this thing here. So you substitute this in here, and you'll find this straight. It's really actually not that. No, just
Pokemon Go every day. I play Pokemon Go. I play Pokemon Go every day. I play Pokemon Go. When I wake up, I'm grabbing my phone.
okay, now, as you can see, we use our same equation we used before, and this is what it looks like right now. See, after 1, it won't make sense because you're going negative down, and pH doesn't have a negative. Now, if you really zoomed in, like around this area, because this one, because knowing that this is almost touching 0, but it's never 0, it would be here. Now, it looks like this, but of course it does make the straight line, so it's around here. Okay, it doesn't reach 0, but it's there. And plotting the points, you would see that it actually attaches itself. Now, if you go to decimals, you can actually see it for yourself, that it attaches onto the line. And yeah, as you can see, this does not exist. Just here to here. And whichever, because the only line that reaches up to 14, pH 14, and causes back down to 1.